Hello, we are going to continue working with solving equations and specifically multi-step equations, which just means we have multiple steps. We need to do more than one thing in order to solve it and find our variable. So we can use this little acronym here off to the left, don't call me after midnight, otherwise known as distribute, combine like terms, move the variable, add and subtract, and multiply or divide. We can use this acronym to help us understand the order of which to do the work. If you are able to solve the equation without it, that's totally fine. But if you look at an equation like this and you see there's so many different things going on, you're not sure where to start, then just go through this acronym and it will help you work your way through the steps to solve. All right, so first up is distribute. Do we have anything that needs to be distributed? Nope, I don't see any parentheses, so that can just be marked off, nothing to distribute. How about combining like terms? Ooh, this one's a little tricky. So what I'm going to do to help me answer that problem is I'm going to draw a line through my equal sign. Because when we're looking to see if we're combining like terms, that means we're on one side of the equation. So if I look on the left, all I have is a negative 12. Is there anything else on that side of the equation that I could combine? No. Now I'm going to look at the right. We have 3 minus 2k minus 3k. Do we have any like terms there? Yeah, we do. We have a minus 2k and a minus 3k. So that means I do need to combine like terms. There's a couple different ways that you can look at this to make sure that you get the integer part, so your negative sign, correct. One is you can recognize that a subtraction sign and a minus sign or a subtraction sign and a negative sign are pretty much the same thing. So you could look at it as a negative 2k and a negative 3k. Or maybe your teacher taught you that whenever you have a subtraction sign, you use keep, change, change to make it an addition problem. If that's the case, that's where you keep the first the same, so a negative 2. You change your subtraction to addition, and then you change the sign of your second number, which would make it a negative 3. And I almost forgot my k's. That would be bad. Okay. Either way you think about it, as you recognize that they're both negatives right away, or you use keep, change, change, they both end up to be negative numbers. And when you're adding integers and they have the same sign, you add them and keep the sign. So when working with integers, if you're adding, if they have the same sign, you add them and keep the sign. If we add them, 2 plus 3 is 5. We keep the sign, it will be a negative 5k. And we are going to write down everything we didn't use. All right, do I have any more like terms? Nope, because the negative 12 and the 3, they're not currently considered like terms because they're separated. They're on the opposite side of the equal sign. So they may be alike, but they can't be combined. They're not in the same room, not in the same house. All right, next step is move the variable. Moving the variable will occur if you have a variable on either side of the equation. And that's something that we'll be getting into next. So currently, that is going to be a no-go step for this entire lesson. All right, now add or subtract. Well, we're focusing on getting our variable, our k by itself. So is there anything being added or subtracted to that variable term? Yes, there is. We have a 3 right here. All right, is it being added or subtracted? You might have said subtracted because of this subtraction sign, but the 5k is actually being subtracted from your 3. So that negative, that minus sign there belongs with your 5k because it's right in front of it. Whatever sign is in front of your number, belongs to it, glued together. So nothing's in front of the 3, which actually means it's a positive 3. But what's the opposite of a positive? A negative. So we're going to subtract 3 from both sides. All right, negative 12 and a negative 3, kind of same as up above. They both have the same sign, so we add them and keep the sign, which makes it a negative 15. And then positive 3 and negative 3, they cancel out and equal 0. So we're left with a negative 5k. All right, we're on to our final step, which is to multiply or divide. So again, we're looking, is there anything that's being multiplied or divided with our variable? Yep, I have a negative 5 times k. If we have a number and a variable, one way we can show multiplication is by putting them side by side. It's the lazy way, and mathematicians are lazy when they can be. So the opposite, the inverse of multiplication is division. So we're going to divide both sides by negative 5. All right, we talked about the adding rules for integers. Let's talk about multiplication and division rules for integers. Multiplication and division rules for integers are totally different. This time, if they have the same sign, your answer will be positive. So when multiplying and dividing, if your two numbers have the same sign, your answer will be positive. If they have different signs, your answer will be negative. In this case, they have the same sign, a negative 15 divided by a negative 5. So our answer will be positive. 15 divided by 5 is 3. So a positive 3 equals k. We have finished our steps and our variable is isolated. We know what k is. K, that unknown value, represents a 3. And if you wanted to go back and check your work, you could substitute. So you could plug in 3 for k, back right up here in your original problem. And when you use order of operations to simplify that, you should get the answer of negative 12. All right, now it's your turn to go ahead and try an example very similar to this. So if you need to, take a little screenshot so you can have this example right up next to you while you try one on your own. All right, let's do another example here. Now that you've had a moment to practice, let's kind of come back, take those things that you're like, ooh, I got stuck on this, and make sure as we go through this example together, you take some notes, you pause this if you need to, so you can see exactly where you need some more help, you need some more explanation. All right, we have an equation, which means we want to solve for our variable. We want to find out what it is. So let's use these steps to work our way through to make sure that we can get this done. First, up is distributing. Is there anything that we need to distribute? Yeah, there is. I see a negative 3 being multiplied by a set of parentheses, by being multiplied by something. So we're going to distribute. We're going to multiply this negative 3 by everything inside the parentheses. So we can continue to practice those multiplication rules of integers. So when we're multiplying integers, if the numbers have the same sign, your answer is positive. If your numbers have a different sign, your answer will be negative. So a negative 3 times a positive 4r. One is negative, one is positive, different signs. So our answer will be negative, a negative 12r. Now we have a negative 3 times a minus 8. Remember that the sign in front of the number belongs to it. So you can look at that as a minus 8, or you can look at it as a negative 8. It's really the same thing. I said this earlier, but now it's kind of explain why. If we kind of think about grammar, if we think about English, there are multiple forms, there are multiple synonyms and tenses to the word run. So you can say you run, you jog, you ran yesterday. All of those mean the same thing. But depending on how you're saying it, depending on your vocabulary choice, you could use a different word to represent that running movement or that jogging movement. Same thing applies to this. Depending on how you see it, you could say it as subtraction, you could say it as negative, but it really boils down to mean the same thing. All right, with that being said, that means these numbers have the same sign. I have a -3 and a -8. When multiplying and dividing, if they have the same sign, your answer is positive. You will have a positive 24. And then I don't need to distribute to anything else because you only distribute to what's inside the parentheses. So we'll bring down our equals -36. All right, next up is combine like terms. Once again, I'm going to draw a line through my equal sign because when we're looking to combine like terms, we're looking on one side of the equation. So we're kind of looking at it like it's an expression, because an equation is two expressions set equal to each other. So if we look at the left here, -2r plus 24. Do I have any like terms? Nope, and why not? Because one term has a variable r, the other term does not have a variable, so it's called a constant. If I look at the right side, all I got is a -36. There's nothing even over there that could be a like term. It's all by itself. That step can be skipped. Same with move the variable. I don't have a variable on both sides, so that can be skipped as well. All right, adding or subtracting. Is there anything being added or subtracted to our variable term? There sure is. I have my variable term, which is -12r, and I'm adding 24 to that. Well, whenever we cross over to that other side of the equation, we have to do the inverse. We have to do the opposite when we cross over that line. So the inverse of adding 24 is subtracting 24. Subtract 24 from both sides. Nothing was subtracted from your -12r. That just comes right on down. Positive 24 minus 24 is 0. That cancels out. And then now we have -36 and -24. Adding and subtracting rules, if they have the same sign, you add them and keep the sign. Different signs, subtract them and take the sign of the larger absolute value. Well, they have the same sign. I have a -36 and a -24. I'm going to add them and keep the sign, which would be 60. We have a -60. All right, last step is we need to either multiply or divide. What do we have going on here? It may be easy to think that because you see a -12, you need to add the 12. But that's not the case. It's not r minus 12. It's -12 r, which means -12 times r. We have multiplication here. You could even like put some parentheses there to help recognize that that negative belongs with your 12. What's the inverse of multiplication? Division. So we're going to divide both sides by -12. -12 divided by -12 is 1. It cancels out and we're left with a single 1r. You technically could write a 1 right here because there's 1r left. But like I said earlier, when mathematicians get a chance to be lazy and not write something, they take it. So if there's a single r there, it's just expected that you recognize that there's only 1r there. Therefore, there's one of them, and you can write the 1, but you're not required to. And then negative 60 divided by negative 12. First, if we look at our signs with multiplication and division, those rules are different. With multiplication and division, same sign, your answer will be positive. Different signs, your answer will be negative. Negative 60 divided by negative 12 is a positive 5. So we're left with r equals 5. R is all by itself. We have finished our steps, so we're good to go. All right, once again, it's your turn to try something out. So if you need to, take a screenshot of this because you're going to have an example that is super duper similar. All right, we are now into that last part of our lesson here, and we are going to take a word problem, write an equation, and then solve it. And yes, this is something that you possibly could use like a guess and check, a trial and error method to solve, but it's not as efficient. Therefore, if we can, get good at writing equations, it will be a little bit more efficient in solving these, which I personally like efficiency because that saves you time, because I know we all have a lot of stuff going on. All right, let's read our word problem here. If 5 is subtracted from 3 times a certain number, the result is 10. Write, oops, I got a typo. Write an equation and solve to find the number. All right, now that I've read it once, I'm going to read it through again, and this second time I'm going to annotate it. I'm going to mark it up. All right, if 5 is subtracted from, okay. So it tells me subtraction is easy, but it's saying it's subtracted from, which means it's kind of like a backwards thing. That means it's going to be after whatever comes next, because it's subtracted from that next thing. So that minus 5 is going to need to be after whatever we read here. 3 times a certain number. Well, what do we use when we have an unknown amount? We have a certain number, but we don't know what that certain number is. We use a variable. You could pick any variable you like. I'll choose X because that's usually the most popular one. The result is means it's equal to 10. All right, for the most part here, we've actually kind of written our equation directly above the words. All right, 3 times X. And remember, you can write multiplication however you want, with a dot, with an asterisk, with parentheses. But typically when you have a number times a variable, they're just written side by side. That's the most common way when you have that combo. And then 5 is subtracted from that. The result is 10. Before I go ahead and solve this, I'm going to read this one final time to make sure that it really matches my equation. Because if my equation is wrong, then everything I do from here on out is going to be wrong. All right, if 5 is subtracted from, yep, I have a minus 5, and it's subtracted from, so after, 3 times a certain number is 10. Yep, it matches right up. So now we're ready to solve. All right, this technically right here, guys, if we look at this, this is what would be considered a two-step equation, because I don't really have a lot going on. I don't have a bunch of parentheses. I don't have a bunch of like terms. I don't have a bunch of variables. So if you're able to look at this and you remember those final 2 steps, cool beans, go for it. But if you were still a little shaky on the 2-step equation, you can use this acronym still. This acronym works even with a 1-step equation, all right? You just may have a lot of things that you don't have to do. All right, let's look at the very beginning here. Distribute. Do I need to distribute anything? Nope, I don't have any parentheses to which would cause distribution. How about combine like terms? Nope, because when we look at this, we separate our two sides here. And all I have on the left is a 3x and a -5. They're not like terms. And on the right, I just got a lonely old 10. So skip that step too. Move the variable. Nope, I don't have a variable on both sides. No need to move it. So now we're down to add or subtract. Is there anything being added or subtracted with our variable term? Yeah, a 5 is being subtracted from our variable. So that is our first step that we're actually going to complete. With that, what is the inverse? What is the opposite of subtracting 5? Adding 5. We will add 5 to both sides. So nothing changed with that 3x. We're just going to bring them down. -5 plus 5 is 0, so it cancels out. And 10 plus 5 is 15. All right, next. Multiply or divide. Yeah, 3 is being multiplied by x. What's the inverse of multiplication? Because we need to do the inverse since we're crossing over, since we're going over to that other side. The inverse of multiplication is division. 3 divided by 3 is 1, so it cancels out and we're just left with x. 15 divided by 3 is 5. And we have solved it. So we wrote ourselves an equation and we found that this certain number is 5. That is the only value that would make this word problem true. All right, for one final time, guys, it's time for you guys to try something on your own. So just like before, if you need to, snap a little picture of this so you can have an example of how I marked things up, because you guys can do the same. All right, good luck. You got this.